Hello everyone, I am Dr.Krishna Sarker. Here in this session, I will be going to discuss about Polar and Nyquist plot for type 2 system. This is linear control systems, lecture series on linear control systems, lecture number 56. So our target, Polar and Nyquist plot for type 2 systems. For type 2 system. Suppose the given open loop transfer function g of s h of s equals to 1 by s square into 1 plus s. This is type 2 system. This is type 2 system because s square. Because in this case s square, when 1 by s to the power n, this is type n system. When n equals to 1, type 1 system, n equals to 2, type 2 system, n equals to 3, type 3 system. So in this case, this is s n equals to 2. That's why this is type 2 systems. Draw Polar and Nyquist plot and determine the stability of these systems. Draw Polar and Nyquist plot and determine the stability of the system. Solution. Solution. First, pole zero location. Pole zero location. Pole zero location. What is the pole zero location? The given transfer function g of s h of s equals to 1 by s square into 1 plus s. That means s equals to 0, 1 pole, s equals to 0, another pole, and s equals to minus 1. The pole locations are s equals to 0, 0, and minus 1. Then plot the pole 0. Then plot the pole position. What is the pole position? This is the imaginary axis or y-axis. This is real axis. So write down here, real axis. This is real axis and imaginary axis. At origin, s equals to 0 and another pole also s equals to 0. And s equals to minus 1. This is the left hand side and this is right hand side. All the poles and zeros left hand side of the S-plane. So open loop system will be stable because all the poles and zeros left hand side of the S-plane. That's why open loop system stable. Then step number 2. Nyquist contour or path. Step 2. Suppose this is the real axis and this is the imaginary axis. Then this is real, this is imaginary axis. Then draw Nyquist contour, path, right hand side, because if left hand side, in this position 2 poles, s equals to 0, s equals to 0, and s equals to -1. This is the clockwise contour. Suppose this is J infinity minus J0 plus J0 point, and this is minus plus J infinity point. And this weight C1, this is the weight C2, this is the weight C3, and this is C4. And the radius R tends to infinity. And this small radius epsilon tends to 0, but not equals to 0. So what is the weight of C1? C1 belongs to, this is the C1 path. This is the C1 path. So minus J infinity 2 plus minus J0. C2 belongs to this path C2. So minus J02 plus J0. And C3 belongs to plus J02 plus J infinity. And C4 belongs to plus J infinity 2 minus J infinity. This is the Nyquist contour or path. If left-hand side portion zeros, then system will be stable. Just calculate right-hand side Z of value. If Z equals to 0, system stable. If Z has some values, then system unstable. Then step number 3. Step 3, put S equals to J omega. Then when S equals to J omega, G J omega, H J omega equals to 1 by J omega square 1 plus J omega. For sinusoidal input, G of J omega, H of J omega equals to magnitude of G J omega, H J omega, angle of G J omega, H J omega equals to m into phi. Then magnitude calculation. Magnitude calculation. Magnitude m or mod of G J omega, H J omega equals to mod of 1 by J omega whole square 1 plus J omega. This is equivalent to 1 by omega square 1 plus omega square. Phase angle calculation. Phase angle calculation. What is the phase angle? Phi equals to minus 180 degree for this term and minus tan inverse B by A omega. This is the phase angle. Then calculate omega m phi, that means magnitude, frequency, magnitude, and phase angle. So what is the step? Step equals to 4. So phase angle magnitude equals to, first magnitude equals to, what is the formula? This is very important. Omega square 1 plus omega square, and phase angle phi, angle of G J omega, H J omega equals to minus 180 degree minus tan inverse B by A. Then calculate omega m and phi. First value always 0 and last value infinity. So first put omega equals to 0, something by 0 infinity, and this value 0, then minus 180 degree. For type 2 system, always starting from minus 180 degree. And when omega equals to infinity, something by infinity is 0, and phi equals to put here infinity, that means 90 degree minus 270 degree. So step 5, polar plot. Polar plot. Draw first polar plot. What is the polar plot? Design of polar plot. Just this is imaginary axis. This is real axis. So omega m phi, draw with respect to omega equals to 0, m equals to infinity, phi equals to 0 degree path. This is omega is to 0, m equals to infinity, phi equals to minus 90 degree. And this direction, omega equals to 0, m equals to infinity, and phi equals to minus 180 degree. And this is omega equals to 0, m equals to infinity, phi equals to minus 270 degree. At origin, omega equals to infinity and m equals to 0. Then draw the polar plot. What is the polar plot? First value, this is the first minus 180 degree path. Magnitude equals to infinity. This is the value, omega 0, m infinity, and minus phi 180 degree. And the terminating point, omega infinity, that means origin. M0, that means also origin, and passing through minus 270 degree path. Passing through minus 270 degree path. This is the 270 degree path. So this is the polar plot. This is the polar plot. And the Nyquist plot, what is the Nyquist plot? Just mirror image. This is the Nyquist path. And this distance infinity. So minus 1 plus j0 point inside. Minus 1 plus j0 point. Minus 1 plus j0 point inside. Then the stability. Stability. What is the stability? N equals to P minus Z. N equals to number of contour. In this case, if this figure, then the contour equals to 1 and clockwise. This is the negative 1 and pole, no poles right hand side. That means 0 and Z. Z equals to 1. That means open loop system stable, but closed loop system unstable. Because Z has some value, system will be unstable. So in this case, system unstable. If the figure starting from infinity, just draw. This is the figure starting from infinity, just previous figure. Suppose this is the infinity distance. In this case, omega 0, m infinity, phi minus 180 degree, and terminating point omega infinity, m0, phi minus 270 degree. Suppose this is not breaking, just this is the polar plot. And corresponding Nyquist mirror image, this is the mirror image. Then draw contour. This is the contour. Actually, this is the terminating point, last point. This is the terminating point. This point, terminating point. So this is the contour. Then n equals to p minus z. This is one contour. And this is another contour, and clockwise, CLK, negative value. Then n equals to -2, p minus z, p equals to 0, z equals to 2. So system unstable. System unstable. This is the conclusion. So what is the main basic idea of the second type 2 system, or of the type 2 systems? First problem, for type 2 system, first problem, G of S, H of S equals to what? 1 by S square. And this is the plot. This is the plot. Starting from this point, this is the polar plot, and this is the Nyquist mirror image, just opposite direction. And when G of S, H of S equals to 1 by S square, S plus 1, then what is the conclusion? Starting from same point, but one coordinate shift, passing through minus 270 degrees. And this is the mirror image. But when G of S, H of S equals to 1 by S square, S plus 1, 2S plus 1, then again, starting same point, the same point, this is the polar plot. And the Nyquist plot equals to, mirror image equals to this. So this is the polar direction, and this is the Nyquist direction. Similarly, when G of S, H of S equals to one pole, again added, G of S, H of S equals to 1 by S square, 1 plus S, 1 plus 2S, 1 plus 3S. Then the polar plot, first draw polar plot, starting point, same point, but this is the polar plot. And what is the Nyquist plot? Mirror image. This is the mirror image. This is the mirror image. So, basic idea of the type 2 system for calculation of stability, or actually type 2 system, for type 2 system, So G of S, H of S equals to 1 by S square, 1 by S square in one pole added at S plus 1, again another pole added to S plus 1, again 1 plus 3S, another pole, then the construction of polar and Nyquist plot. So thank you for